Well, first of all, I would like to thank SECPHO once again because of this fantastic proposal of doing those webinars. I think this is very, very helpful to connect ones to the others. Then, okay, my name is David Castrillo. I take care of the Spanish office. I also have one colleague in Portugal. And the topic here that I decided is, okay, we know that the virus can stay in surfaces. So here we're thinking one of the options for the post-COVID area is to improve developments of the human-machine interface. So first I would like to, let me say, just a few words, sorry, on the company. The company Hamamatsu is a Japanese company. It was founded in 1953 by some former students of the inventor of the TV transmission that happened in 1926, also in the city of Hamamatsu. The company is, well, I said Japanese, and it grows organically by developing the technology that it's always focused on photonics. There are several offices in the world, like the one close to Barcelona, and those are direct dependent on the Japan because our idea is to help to develop the technology requested by the customers, and the only way we have is to make a strong connection between the person that has the application here and our engineers in Japan. I do not plan to go to the list of detectors because it is too wide and too confusing sometimes. I just want to say that we have UV light emitters, even in the extreme UV, and we also have infrared detectors. If we want to see better what we have, we have this slide that organizes our markets in kind of 3 lines. In the bottom line is the markets that we deliver the component. It means that the customer usually has to add an amplifier or electronics or even solder the component. This is the case, for example, of the detectors that we do for the PCR detectors for the COVID. We made just the detector. In the middle line, we have the modules. Modules is something that can be integrated by the development of software or some basic interface. This could be the case of spectrometers or cameras. And in the upper part is what we have a kind of an end solution for the end customer. But here mainly is microscopic imaging systems for biology or for the semiconductor industry, and we have other. The topic today is the human-machine interface, but we already have classic technology for that. So we have those photo detectors with an integrated circuit. It means an ASIC that is dedicated for a specific function. Those are the ones that we can get when we wash our hands or when we use a hand dryer. We also know that in the past we had these pyroelectric detectors to open our doors, and in some cases they are substitute for range detectors also. And quite recently, because of the popularity of the cleaning robot at our homes, we also developed a kind of distance image sensors to make a recognition of the environment in order to move the robot. So it is based on this technology that we are going so I'm going to explain. This is the model. This is not a finished model yet, but it is something that we want to finish very soon as a kind of a 3D sensor model. This 3D sensor model is based on a kind of light ranging detection. But if we move to the kind of light ranging detection, we can think on LiDAR, and this is a different technology. It means this is not the direct time of flight detection that we use or we plan to use also in the cars. It was in another topic that we explain another time. But this is a kind of indirect system that is more based for a very close distances and up to, let's say, 10 meters. So in both cases, the principle of the operation is the same. So we have a light source, and we detect the reflection of this light source on the object. But in the direct method, what we do is we count the time between the emitted light and the detected light. This is the one that we use for the automotive, for example, 200-meter range, this kind of application. In this case, the pulse, we detect for each pixel of the image, we detect, depending on the time, the charge in one well or in another. And by doing the ratio of both, we can detect the distance. This is because the pixel structure is not the typical one, but the electrons detected goes to one well or the other. So we see in time one, then we move to the second, and then back to the first. And by doing this ratio between the two, we create the calculation of the distance. We are improving this kind of, this is the second generation that we are just releasing now with a very, very high sensitivity at 940 nanometers. And we have in linear, because for some application in robotics is enough, and we have also in area. And we have some evaluation kits used to help to test if it can work for the application of our customers. So in fact, what we will have in this model, because right now it's just a prototype, we have the sensor, but we also have the ASIC and all the calculation of the distance. And we also have the laser. We also make lasers with the driver. All is made, designed, and produced by Hamamatsu. Here we have a kind of a video. We have a video. We have other videos in the website that shows. So here, let me just, here we have the emitter and the sensor, and here we just place kind of a glass just to have kind of a sense of the touch, but it can be nothing. So we can just make here like a barrier in the air. So what we see is, okay, all the optics are designed to make the detection at this distance, and then you are touching, it's not a capacitor screen, so it's just detecting by the reflection of the light. So you can do it even having no screen. You can, because it detects the distance from the emitter or the sensor to your hand. You can use also to move. We are strongly convinced that this kind of technologies will spread more, and there are different ways to do it, but this is just one of the possibilities. We are developing technology, and we are following what our customers need. So, So this is the end of my presentation. We have other videos that helps also to count people or to do some other applications. If any question, please contact me.